Here we're asked to graph y equals the absolute value of 2 times cosine of x over 2. And so, very straightforward problem if there's no absolute value bars, and I guess at the end we just have to figure out what the absolute value does. But I'm going to give myself an easier problem to deal with. Since I think the problem is easy if there's no absolute value, I'm going to start with that. And this is a good problem-solving strategy in any math class. Take some problem that looks hard and ask yourself, well, what old problem does it remind me of, and is that easier? And if you can find an easier problem that looks like the one you're given, that's always a good place to start. Because if we can't do the easy one first, then we're not going to be able to get through the hard one anyway. So when I'm looking at this, the amplitude's 2, period, 2 pi divided by 1/2, because x over 2 is really a 1/2 x. So my period's going to be 4 times pi. There is no phase shift. There's no vertical translation. So if I sketch this, my easier problem, not too hard to divide up the x-axis here. My amplitude's 2. And I can imagine what my cosine graph is going to look like here. Plotting those 5 key points. So there's my graph of y equals 2 cosine of x over 2. All right, well, let's see. I'm going to give myself another set of axes that's divided up just like those. And I think about what absolute value does, right? If something's positive, it leaves it alone. If something's 0, it leaves it alone. If something's negative, it makes it positive. So when I look at my graph, well, the absolute value is not going to affect that first bit at all, because the absolute value of a positive number is itself. But now what I realize down here, any part of the graph that's less than 0, my absolute value function is going to turn that into a positive number and turn it over the x-axis. All right, and then I get to the end, and again, part of it is just left alone. And there I have it. There is that nice shape of the absolute value of 2 times the cosine of x over 2. You could even imagine continuing that pattern out. One interesting question you can ask yourself, what's the period of this new function we've created?